Hi guys, do you ever have challenges in managing your outgoing, your egress internet traffic? Let's say you want your public cloud user can upload to public cloud service through your direct peering for low latency and better internet access, while your low priority internet user will upload their YouTube video through your other transit peering. In this video, I'm gonna explain and demonstrate how to engineer your internet gateway using peering fabric network automation so that you can manage the egress internet traffic based on low latency peering, low cost peering, load sharing, priority list, and it's only apply for specific internet application. This demonstration will use Cisco peering fabric router and design, leveraging Cisco segment routing and Cisco NSO Network Service Orchestrator, the automation software solution. This video is part of Cisco Peering Fabric demo series, and my name is Hinwato. I'm a Cisco Technical Solution Architect, a CCIE and a CCDE. You can get more information of Peering Fabric network automation. Please sign up to ciscolive.com and access to the Cisco Live session, Intelligent Peering Fabric Network Automation Use Cases. There are complete slide deck and demonstration video.
Let's get started. This is the exciting time to have a demonstration. Before that, let me explain the topology in the demonstration. I still use the same topology like the beginning here. We have 8 routers. This lower green block is the SP network together with the router 6. We have established the EBGP session across these peer links here. Router 8 and 5 are the internet router. And then here on the router 1, 7, 3, and 2 and 4 are the distributed peering fabric, which is a span and leaf approach here within the AS65000. While the router 6, it is a standalone peering fabric node here. And we use the IGP with the segment routing, and NSO and SR-PCE here, as well as the telemetry. So in terms of the links, we categorize 2 links. The green solid links are low latency link, and the dotted link and red are the normal links here. And NSO will actually configure router 6, 7, 1, 2, and 4 here. So I will use the dummy prefix here. I set the Google prefix to use a 100, Facebook 101, and so forth. It's actually advertised by router 5 as the internet gateway, internet router here. And for the customer prefix, it will be advertised by router 2 or 4 with this prefix, and router 6 with this prefix 60. Okay, and later we will use trace route to verify the network changes. On the NSO, I will demonstrate the service modeling here. We have the application model for the application list and information, and we will set up the gateway policy here for the domestic. Here, let's say this is domestic. The gateway node, we will configure specifically only these 2 nodes to a internet gateway, router 2 and 4. And at this moment, I specifically assign the low latency peer statically. Yeah, and also low cost. Actually, we measure it from time to time. or the low latency, which peering has the best low latency value. You can also do it dynamically with another automation software. So, but it's not in this demonstration. And then for the ingress policy here, for the ingress for the prefix ID cloud, we will assign which part we prefer, is it low latency, low cost, or which scaling you would like to assign. Same as for the egress or the outgoing destination. We will have the menu to select which egress part or outgoing part we want to use here. This is for the standalone. Actually, we have the same policy configuration or menu here. We will apply on the router 6. Okay, here I will start using the desktop, and we can start build. First, I will prepare the ID gateway first on the node 2, right? So this, I will open my NSO. This is the NSO web UI. Select the service manager. I have built the peering service here. We will set up a new gateway, ID gateway, and this ID gateway, we have already custom the menu. This is part of the domestic gateway, and the domestic gateway currently only has 2 options, 2 nodes, node 2. Here, I will assign statically first. The low latency peer is the AS6, is linked. And then the low cost peer in this demonstration is AS-1, is linked, AS-1. And then I will advertise the customer prefix of ID cloud. And this is the ID cloud 1, right? And this is for the ID cloud 2. Okay, all these menus are custom made. This is intentionally prepared for the demonstration purpose. Every use case, every service later, we will custom based on your requirement. So then the changes we need to commit. Let's see on the native configuration with the CLI format. Here, it will configure node 2 to advertise the network on the BGP. Let's check on the router 2. Here, we don't have any network advertised yet, right? And let's check on the router 5, which is on the internet router. We have prefix 20. No, not yet, right? Now, we will commit this configuration to the router or to the internet gateway 2. We select commit here, the ball is rolling, meaning that the NSO will connect to the internet gateway 2 and start configuring the policy changes. Here, right? Okay, done. Let's check again on the router 2. is router 2. Okay, we have it now. NSO has configured this router 2. And let's see whether this advertisement, the traffic advertisement already reached router 5. Okay, we have it now on the router 5. Now, let's verify the normal path first. We would like to verify the normal path for the ingress, for the incoming. So I will trace route from router 5, the internet router here. So I will verify all these 3 prefixes. This is toward the ID cloud. Here, the traffic flow is via 1, 3, and 2. Just look at the last number. It shows which hop of the router. 1, 3, 2, right? And then that's 1. This is for the ID cloud 1. Same path, 1, 3, 2. And this is for the DAS 2. Same path, 1, 3, 2. So all traffic flow to these 3 customer prefix using the same path, 1, 3, 2. Yeah, of course, this is the BGP best path flow, right? And then let's verify the egress, the outgoing from router 2. So this is router 2. I will use trace route to, let's say, Google. Actually, the dummy prefix here, you want to verify the path 315. 315. And let's click. This is also the dummy prefix 315. Same. Okay. So now this is the path in the normal condition based on the BGP best algorithm path. Okay. Okay, let's continue in the peering traffic control for egress, outgoing traffic. So yeah, on the egress, we leverage the segment routing on the BGP egress peering engineering label, which is a BGP peering sheet. You can see on the configuration here, on the neighbor, this is point of view on the router IGW1. So on the neighbor router 8, so we configure the egress engineering. So it's actually establish the BGP session and assign the BGP peering sheet for this peer link 80,140 here. And it also applies for every peer link here. And this BGP peering sheet, we use it as part of our segment routing segment list, right? So we assign it here on the peer label NSO Service Model. So let's say in this case for the AS5, this is the peer label, the BGP peering sheet. Then it's configured on the router 2 and 4, and also on the router 6. If we take a look on the router 2 here, I have configured it for the sake of time. If I go show segment routing, show run segment routing, I have this segment list 15, meaning that I will select the IGW1, which is this is the IGW1 loopback from router 2 to router 1 here. And then I will select this BGP peering sheet, which is the peering link to AS5. This is 8 and so forth, right here, right? And later we can assign this segment list into our segment routing policy and traffic engineering. This is how we have the flexibility and simple way and automation way to control our egress, outgoing traffic. Let's go to the use case now. So here, based on the low latency for Netflix, So I have on the router 2 now. I have the menu here, egress for the outgoing. I select it here, destination for the Netflix. And then let's select the egress path based on the low latency. That's it. Let's go to commit. I can show what happened on the native CLI first. Remember that normal egress is 2315, right? We have tested earlier. So here on the router 2, we will configure the segment routing policy for Netflix, and we will use this certain segment list based on the low latency policy. So commit. Okay, while it's moving, we can try to verify it. Netflix, right? This is still normal path, still configuring, not finished yet. The ball is still rolling. Let's compare it after it's done. Okay, it's done. Compare again. We expect to follow the green link. First is 4, then 3. This is the green link, the low latency link within the SP network, and then reach our border internet gateway router 7. Then use our direct link or the low latency peer link 6, and yes, reach our router 5. Here. Then for the low cost, similar for what apps? YouTube here. Let's assign that YouTube. Every upload to the YouTube, we'll use the low cost peer link. And within the network, it's still normal link. It's okay. YouTube, low cost. Then I just straight to the commit. Right? Let's try YouTube. Before it's done, still normal path 315. Now you want to redirect or to steer towards 818. Okay, still rolling now the ball. You can see that I demonstrate this policy changes. It's very fast and agile way. Now it's done. And only apply for certain traffic, certain customer, without impacting the global customer. Okay, 3, 1. Okay, now go to 8 first, and finally reach 5. This is the low cost. Then, priority, similar to our use case on the ingress. Okay, for Google. This is similarity for Google, right? Okay. Now, select for Google. Priority. Let's do the priority here. Then I will only configure 2 for the sake of time. First peer is AS87. Follow the diagram. And second peer is S-1. Second pair is S-1. Okay. Then let's take a look at the CLI. What happens on the CLI configuration? We leverage segment routing policy features here, which is the preference. See here? The higher the preference, the higher the parity, the preferred one. So first, we select the 7/8 because this is 40 compared to 30. Lower parity is 1/8. Actually, I prepare the other 2 because we have 4 peer links upstream. Okay, let's go for commit. And this configuration changes only apply on the Internet Gateway 2. So let's say we have other Internet Gateway 4 on the other data center or other feature routers. then we can have very specific policy without complicated on the global changes there. And okay, I think it's done now. Let's verify it. Router 2. So it's Google, right? T1 Google is a dummy prefix. Now Google goes upload to 7, 8, and 5. I want to verify whether it works for the second pivot. I need to shut down or shut the BGP session here. Python node 7 BGP 78, right? I will down the BGP 78 again. Okay, let's verify it. We expect it will go to the second parity part.
This meeting is being recorded.
Okay, let's verify it again after the link on the H.7 down. So I go to the router 2, verify to the Google again. Now it's like 3, 1. Okay, 3, 1, 8, and 5, right? So it goes to the 1 and 8. So the second, the parity, like as expected. Okay, next go to the next use case. This is load share and the gateway specific. So go to our NSO. The gateway specific means that we will use the gateway 4 here. So in this case, let me delete the gateway 2 here. And I will configure a new gateway here. This is gateway ID 4. Then here, we'll select this is domestic one. And this is the gateway 4. Right? And our low latency. So give it for the sake of time, and I will advertise this. I will also advertise the prefix now. And select the egress policy specifically for Facebook, for example. And the egress part policy is load share. And I will select only 2 load share for the sake of time. The peer RS H7 and H1. H7 here. I will also share it with the peer RS H.1 here. And I will assign the weight. H.1 is weight 1. H.7 is weight 2. Okay, let's see what happens on the CLI configuration changes. It's actually leverage the SR policy feature as well. With the load share, unequal load share capability here. Yeah, it's preparing. Okay, on the node 1, we will undo all the policy, the ingress. On the node 2, remember, we delete the policy there, here, all. No on the node 2. And also on the node 4, we prepare a new policy here, right? And we prepare the segment routing unequal or not balanced load share here with wait 1 and wait 2 for the Facebook. And node 7 we also undo all the BGP ingress policy like we have done on the gateway 2. Okay, I think we can do the commit here. You can see the NSO really helps us on do end-to-end service policy changes, download here, delete here, set up on the other internet gateway router simultaneously at the same time. And okay, I think I have, yep. Actually, there's changes on router 7. Remember that I sent Python execution, right, on the router 7, changes manually. And the NSO informed me that actually it's a device is not synchronized with the NSO, that I need to synchronize it again. That this is the way that NSO will become the source of the truth, single configuration source. That actually any changes without NSO policy or NSO action, that NSO will stop the execution and will revert back to us whether you believe with the changes on the router, or we can just do the sync from and synchronize from the router again, or sync to the router again. So that's another advantage of the router. So I think I can go to commit again and execute the changes here. Okay, so let's wait for a while. Before that, let's verify it. So it's Facebook, right? And I think still goes. Because I haven't advertised my prefix. Now it used to be goes to the router 4. Okay, it's done. Let's check on router 5 whether he got the route now. Okay, he get it. Now I can do the trace route from router 4, not router 2 anymore. So T1 Facebook. Okay, now it goes to the 3185, right? And then actually the load share based on the traffic flow, based on the flow, then every other different flow will use a different path. Okay, I think that's conclude this egress policy use case. I hope you guys can follow the demonstration and really see the benefit of this intelligent peering fabric automation. So I like you guys to have the key takeaway. We have addressed and we have built our automation to solve all these peering use cases. The ingress peering automation, the incoming based on low latency, based on low cost, based on telemetry, right? And also the egress, the outgoing, the outbound automation based on this parameter all together. As well as we can have the inbound, the ingress, and the egress outbound resiliency with prioritization. Very simple manner. Just a matter of click and define it on the NSO or through a REST API for all together policy. And we also can leverage NSO capability to automate the gateway policy motion in case you want to swing from one gateway to another gateway for the policy. And we can have the very specific destination policy, as well as it's very scalable. We can start from our integrated standalone internet gateway to our distributed peering fabric. So the peering fabric solution that I have just demonstrated is consists of this network design, our Cisco peering heavy platform, iOS XR is the key, and Cisco iOS XR telemetry as well. We can combine with the crosswalk or open source telemetry stack. The segment routing is the very key factor here. You can see here. It's very flexible, very granular, and very simple to configure, as well as the ODN, on-demand NSO and path computation element, and of course, our main automation software, NSO, Network Service Orchestrator. Okay, so it is the Fidelity design. It's very reliable. It can be very scalable, can be very granular, telemetry based, and very fast. You can see I have done all the use cases within this less than 2 hours, I can say. So now, very faster time to revenue. We can optimize our peer link utilization, and of course, most importantly, we can improve our customer internet service experience. So I like to record this Jack Welch quotation. I think very good. Control your own destiny, or someone else will. In our case, control your own multi-cloud and peering traffic, or something, or someone else will. That's from the Peering Fabric Network Automation. So this is the additional peering resources you can revert to. Please take a look. It's very good document, very well documented, and a lot of resource. I love this all blogs and the segment routing resource. Very good books from Clarence and Chris, which are segment routing books part 1 and 2. Looking forward to part 3 for the SR-PCE, as I know. And yes, please check my YouTube channel as well. I have recorded some segment routing use cases, as well as with the segment routing policy or path computation element and NSO in terms of the transport and VPN service and architecture of transport as well. I think later I will add more video recorded there. And also the segment routing channel on the YouTube. Yeah, it's very good. I think, hope you get very useful this session. Thank you. Feel free to reach me for any update or for any concern. Thank you very much.